Hello grade 12s and welcome to another exam practice video on electric circuits. This question says, the circuit diagram represented below is used to investigate the relationship between current in and potential difference across resistor R. So we're quite familiar with this investigation because we actually perform it in grade 11. And we see over here that the battery has no internal resistance, or if there is any internal resistance, it's not shown on this diagram or in the circuit diagram. There's a switch that is currently open. We see resistor R over here with a voltmeter that is connected across it. The ammeter is in series with the battery and resistor R, but in series with both of these is also what we refer to as a variable resistor or a rheostat. In this case, we are making use of this rheostat in order to change the potential difference. And I know this because if we take a look at the results that are given in the graph below, we see that potential difference is given on the x-axis. Remember, on the x-axis, we plot the independent variable. This is the variable that we change ourselves, that we decide to change and how to change. On the y-axis, we have current. And since the current is plotted on the y-axis, we know that this is the dependent variable. This is the value we're interested in measuring, which changes as a result of the independent variable. So, variable resistors or rheostats can be used to change the current in the circuit, or they can be used to change the potential difference. In this case, since the potential difference is the independent variable, we are using it to change the potential difference, specifically the potential difference that is being read over resistor R. We know that when the resistance of the rheostat is very low, then since potential difference is divided in series, the potential difference reading across the rheostat will also be low. But if we adjust the rheostat resistance to be higher, then we know that the potential difference measured across it will be higher, and therefore the potential difference here will be lower. So that is how we are using the rheostat in order to change the potential difference that is read across resistor R. So now we see when we analyze the graph, we have a straight line graph. It's got a positive gradient and it cuts through the origin where y is 0, or our y values, the current is 0 and potential difference is 0. They now say for this investigation, write down the dependent variable. So we have already come to the realization that current is plotted on the y-axis, and we've reminded ourselves that on the y-axis we plot the dependent variable. So the answer to question 8.1.1 is in fact current, and for writing that down we obtain 1 mark. Question 8.1.2 says, for this investigation, write down the controlled variable. Now, when we are conducting an experiment of this kind, where we are dealing with an electric circuit, and over here we are actually investigating Ohm's law. We know that temperature does affect the resistance within the circuit. We therefore would like to keep the temperature constant, and for writing down temperature you're going to get your 1 mark, since temperature is the controlled variable in this investigation. Question 8.3 says, write down the conclusion that can be drawn from the graph. So again, we have a straight increasing line that passes through the origin. This tells us that we have a relationship of direct proportion, and we can say that the current is directly proportional to the potential difference. If you'd like to, you can say across resistor R, or you can leave it there. Now the word directly proportional takes into consideration that we have a straight increasing line, and also takes into consideration that this line passes through the origin. Remember that if the line does not pass through the origin, then it is not a relationship of direct proportion. Instead, we simply say that as the one variable increases, the other one increases as well. But in this case, since it passes through the origin, the correct term to use is direct proportion, or that the variables are directly proportional. The next question says, the resistance of resistor R must be determined. Calculate the resistance of resistor R by using the gradient of the graph. So when we take a look at this graph, we see that on the y-axis we have current, on the x-axis we have potential difference. When we calculate the gradient, we're going to end up with change in current over change in potential difference, because current is the y values, and to calculate gradient we say change in y over change in the x values, which here is potential difference. When you take a look at this formula, it should remind you of Ohm's law. Ohm's law says that the resistance is going to be equal to V over I. But over here, when we calculate the gradient, instead of having V over I, we have I over V. So what we can do is that we can start off by calculating the gradient, and then we can find the reciprocal. So we choose 2 points. I'm going to choose this point over here and the origin. This is going to be 2, 0, minus 0 as the y values. Then we have 5 minus 0 as the x values, or the current values. When we plug this into our calculators, we obtain a value of 0,4. Now from the gradient we can determine the resistance. The resistance is going to equal to 1 over the gradient. So we plug into this the value of 0,4, and in the end we find out that the resistance is 2,5 ohms. Please do not forget your SI unit. This question is out of 3 marks, so you're going to get a mark for your calculation of the gradient, 1 mark for finding the reciprocal or plugging 1 over 0,4 into your calculation, and 1 mark for 2,5 ohms as your final answer. We now move on to the rest of the problem, which is question 8.2. And this question says, the circuit diagram below shows a battery with an internal resistance R connected to a voltmeter and 2 resistors of resistance 3 ohms and 5 ohms respectively. The EMF of the battery is 20 volts. Now before we go and answer the questions, let's first try and figure out what type of circuit we're dealing with. Let's close the switch, and we're going to make use of a thick and thin pen in order to determine how the current flows through the circuit. So we have positive charges will exit the positive side of the battery. They then will pass this point. Remember that current does not flow through a voltmeter, that is why we pass the voltmeter, and then we get to this point. At this point, what is going to happen is that the current is going to divide. Some of it will go that way and some of it will go around that way. We can see from this that the 5 ohm resistor is connected in parallel to the 3 ohm resistor. And we can see that the ammeter is connected in series with the 3 ohm resistor. This means that the current which flows through the 3 ohm resistor flows through the ammeter as well. Then at this point, we have that the current is combined and it continues to flow towards the battery. We therefore have a parallel connection over here. You're welcome to go and redraw the circuit in a manner that is correct but makes better sense to you, or you can leave it as it is. So now that we know how the current flows, let's answer the questions. Question 8.2.1 says, the EMF of the battery is 20 volts. Explain the meaning of this statement. We can say that this means that the maximum energy supplied by the battery per unit charge is going to be 20 joules. Remember, potential difference is equal to energy transferred per unit coulomb. So here we are saying that per unit charge, 20 joules will be supplied by the battery. This is the maximum amount of energy because remember, EMF is the maximum potential difference that we will measure across a battery. On to question 8.2.2. It says write down the voltmeter reading when the switch is open. So we see that the voltmeter is connected across the parallel circuit. But what we normally try to do when the switch is open is to see if the voltmeter is connected across the battery. If it is connected across the battery, then it means the voltmeter will display a reading. The reading will be equal to the EMF. But if it is not, if it is instead connected across the switch, the open switch, then we know that the voltmeter will display a reading of 0. So we take this side of the battery, we take the other side of the voltmeter and we draw backwards towards the battery, and we see that this side is connected to the negative terminal of the battery. If we go to the other side of the voltmeter, we see that as we draw the line backwards, we get to this point where we have the open switch. So it is not connected to the positive terminal of the battery. And therefore we know that the voltmeter reading is going to equal to 0 volts. Now whenever you have an answer of 0, rather supply the correct SI unit, just in case the markers will only give you a mark if the correct SI unit is given. So this will get you 1 mark, and by the way, your previous answer to question 8.2.1 will get you 2 marks. Now the question says, the switch is closed and the reading on the ammeter is 6 amperes. So let's close the switch and let's go and record next to the ammeter on the diagram that the reading is 6 amperes. Remember that we said that this ammeter is connected in series with the 3 ohm resistor. The same current flows through the ammeter and the 3 ohm resistor. Okay, this is important information. The ammeter is not measuring the total current. Now they say calculate the voltmeter reading V. Here is the voltmeter. This voltmeter is connected across the parallel part of the circuit, this RP, the parallel resistors, or the resistors connected in parallel. We know that the potential difference across the 5 ohm resistor is equal to the potential difference across the 3 ohm resistor, and that is equal to the potential difference across the entire parallel connection. So since we know that this is a 3 ohm resistor with 6 amperes running through it, we can calculate the potential difference across the 3 ohm resistor. We say that V is equal to I multiplied by R. Here we are speaking of the 3 ohm resistor, and if you'd like, you can go and fill in these details. We then have 6 multiplied by 3, which gives us an answer of 18 volts. Therefore, the potential difference reading across or measured by voltmeter V is equal to 18 volts. You're going to get 1 mark for your formula, 1 mark for your substitution, and 1 mark for your final answer. Question 8.2.4 says, calculate the internal resistance of the battery. We are trying to find R. Now I know that this question is only out of 3 marks, but it actually requires quite a lot of calculation in order to determine the final answer. We are looking for the internal resistance over here. And we know that the formula that uses or includes internal resistance is the EMF is equal to I multiplied by the load plus the internal resistance. Now the problem is that we do not know what the current flowing through the battery is equal to. We don't know what the total current in the circuit is. We only know the current that is flowing through the 3 ohm resistor. So that's the first problem. We need to determine what the current flowing through the battery is. The second problem that we have using this formula is that we don't know what the resistance, the total resistance of the load is. We do know the EMF, and we know that we are looking for the internal resistance. So how about we start off by calculating the resistance of the load? I know that some of you may think, but why don't we just say this is equal to V external plus I multiplied by R? Well, the problem we have here is that although we do know the external, because we know that the reading on the voltmeter, which is across the entire parallel connection, is equal to 18 volts. So we do know that value, but we still don't know what the current, the total current flowing through the circuit is. So we're going to have to determine that. And the only way that we can find out what the total current is by first determining the total resistance, or rather the resistance of the load, this parallel connection. So we say 1 over Rp is equal to 1 over 5 plus 1 over 3. We plug this value into our calculators and we find out that it is equal to 8 over 5. Now remember that this is still 1 over Rp. So we find the reciprocal, and in the end Rp is going to equal to a final value of 1,875 ohms. 1,875 ohms. So now we know the total resistance, or rather the effective resistance of the circuit. We also know the potential difference measured across these resistors. So we can use Rp and the potential difference across Rp to determine the total current. We say that the total current is going to equal to V divided by R, where the V is the potential difference across the parallel part of the circuit and R is that of the parallel connection. So this is going to equal to Vp, which we calculated as 18 in the previous question, divided by 1,875. When we plug this into our calculators, we obtain a final answer of 9,6 amperes. So at this point, we know the total current. We can now use the formula written above. We say the EMF is equal to I multiplied by R plus small r. The current is equal to 9,6. R is 1,875, which I have not rounded off because this is not the final answer to the question, and we're still looking for the internal resistance. The EMF was given to us right at the start as 20 volts, so we're going to plug 20 volts in as the EMF. We manipulate this formula and we plug the values into our calculators to find that the final internal resistance is 0,21 ohms. Now again, this question is only out of 3 marks, and I think that it should be out of a few more marks because of how many calculations we needed to perform in between. But in the end, you're going to get 1 mark for your formula, 1 mark for this substitution over here, and 1 mark for the final answer. That is where you're getting your 3 marks. So for all of this, according to the marking guidelines for this specific question paper, nothing was given. Okay, so please be very careful with the mark allocations. If you need to perform more calculations, then you do so. The next question says, the 3 ohm resistor is removed from the circuit. So going back to the circuit now, we are going to remove the 3 ohm resistor. Okay, so this part disappears. Now that we've removed the 3 ohm resistor, the question says, briefly explain why the voltmeter reading increases. Now we've already dealt with a question like this in the previous exam practice video. In this case, however, we are removing a resistor that is connected in parallel. Okay, so when we remove a resistor from a parallel connection, then the total resistance or the load is going to increase. Since resistance is opposition to the flow of charge, we know that if the resistance increases, then the current is going to decrease. Remembering that EMF and internal resistance is constant, we now know that E equals IR plus I small r. Since the current increases and R is constant, we know that this entire part, which is V internal, is going to increase. Since the EMF2 is constant, we know that this means that I multiplied by the load is going to decrease, and this is V external. Okay, so this means that, no, grade 12, I have made a mistake. The current is going to decrease as we just stated. I'm very, very sorry. So let's try that again. So the current is going to decrease, right? This is a constant. So that means that V internal is going to decrease. Now, since the EMF is constant and V internal decreases, in order to balance that out, V external is going to increase. And that is why the voltmeter reading increases. We're going to now state this in words as follows. Remember, it's always useful to make use of bullet points so that you can understand or take note of what points you're writing down in order to get your marks. Firstly, we state that the total resistance increases when the 3 ohm resistor is removed. This causes the current or the total current to decrease. A decrease in current leads to a smaller V internal or lost volt. So V internal decreases since EMF and the internal resistance is constant, and V external thus increases. So there are your 3 marks. And grade 12, this brings us to the end of this question, which was out of 18 marks. There's one more question that I will be going through, one more exam practice video for you to watch, so I hope to see you there.